Okay, Hannah, so this is part 2. I left off the last video right here. Guided practice, page 9, lesson 2, where we're talking about the music room. So what we have to do is we have to find the area of the actual music room. So in order to find the area, we're going to multiply the length times the width of the actual size of it. So right now, all we have is this scale drawing. And so we know that for every 1/4 inch of this drawing, that's equivalent to 3 feet. And I went ahead and just simplified this to possibly check it later. So for every 1 inch, it equals 12 feet because I know there are 4 1/4 inches in 1 foot, which means there's like 4 sections of these feet in this, which means it's 12 feet. So I went ahead and measured this length, and it was equivalent to 2 3/4 inches. And I'm gonna go ahead and convert that into a improper fraction because it's gonna help us multiply later. And so the scale drawing length is 11/4 inches. Let L represent the actual length. So we've got our proportion here of our scale drawing, 1/4 inch over 3 feet. So this is our ratio. And so the same ratio is gonna apply here, 11/4 to whatever feet, whatever the length is actually in feet. So we have 11/4 over L. So we're going to cross multiply to solve this. So we've got 1/4 times L and then 3 times 11/4. And so this part right here kind of confuses me. So I'm gonna go ahead and just continue on down here and write it out a little bit easier for myself. So I know that this is 1/4 L equals 3 times 11/4, which is 33/4. So to get rid of this 1/4, I have to divide it by 1/4. 1/4 divided by 1/4 is equals 1, right? But when I divide it by 1/4, I'm actually multiplying it by 4/1. So I have to do it to this side too. And I think you probably learned about cross multiplication and how numbers can cancel themselves out. So these 4s actually like cancel themselves out, but I'm gonna prove that to you mathematically. So if those 4s did cancel themselves out, you just have 33/1, which equals 33 feet. But to prove that mathematically, I have it right here. So 33/4 times 4/1. Well, 33/4 is 134, and 4 times 1 is 4. And 132 over 4 is equivalent to 33. So our length is 33 feet. So I'm gonna fill that in here. Length equals 33 feet. Now we've got to figure out the width. They already told us that the width is equivalent to 1 1/2 inches, and they converted it for us to 3/2. Let W represent the actual width. So here is my proportion that I have. And then I have what I know of my drawing, what the width of my drawing is, 3/2 over the W. So we cross multiply. So we have 1/4 times W is equivalent to 3 times 3/2. So what this represents right here is just 1/2 W, right? Because you know that 1 times W is going to equal W. So then this would be 9/2, right? So I'm going to bring this down here just to show what this means, this inverse operation. So if I have 1/4 W is equivalent to 9/2, to get rid of this right here, or to get rid of this 4 right here, I am going to multiply or divide it by 1/4, right? Or multiply it by its inverse, right? So here you would multiply by 4/1 to get rid of it. So that gets rid of that. And so on this side, I only have the W, and I've got to do it over here too. So now I have 36/2, which is equivalent to 18. So the width is 18 feet. So when you want to figure out what the entire area, you would do 33 times 18 to get the total feet, which I can't do in my head, so I'm going to do it over here. And that is 0.0333495. So it's 594 square feet, or feet squared. Cool. So this was using that same information from finding proportions and cross multiplying. What does a scale show on a scale drawing? So a scale tells you the proportions of the drawing to the actual figure. Why are scale drawings useful? Because you can make an actual thing smaller or larger. And that's useful. So like a road map, it's useful to have a smaller version of your road in front of you as you are driving or biking or walking, so you can actually hold on to it. Or sometimes you need a larger version or a larger drawing of something in order to be able to actually see it, like if you're looking under a microscope or something. So use the scale drawing to answer the questions below. To the right is a scale drawing of a moth. What is the actual wingspan of the moth? So if the wingspan here is 3.5 centimeters in this drawing, but for each one of these centimeters, it's actually 6 millimeters, you can put your proportions. So you know for every 1 centimeter, you have 6 millimeters, and that you just match them up. So this is 3.5 centimeters. And what is the actual wingspan? And then you would cross multiply to solve that. So I have 1 centimeter times W, so W is equivalent to whatever 6 times 3.5 is. 0, 18, 19, 18, 21, and then it goes right there. So W equals 21 millimeters. Cool. All right, so then you can continue to do those using the same idea of cross multiplication. All you have to do is just make sure you match them up and then cross multiply and use algebra to solve. So I want you to go ahead and do the rest of these and see what you come up with. You can Google chat me or email me if you have any questions about this, and I'll help answer them. And then the last thing we're gonna work on is constructing geometric shapes using all of this information that you just came up with. So one way to construct geometric shape is such as a triangle is to use a computer drawing technology. Another way to do it is by hand using a ruler, a protractor, or both. If you draw by hand, you can use trial or error to determine if it's possible to draw one unique triangle, more than one triangle, or no triangle given a certain conditions. It's often helpful to try drawing different types of triangles, such as acute triangles, obtuse triangles, or right triangles. You can also use several theorems to determine if a certain triangle is possible. So there's 2, and I think we went through this in MTSS also. There's 2 different theorems to think about here. A triangle angle sum theorem, and we talked a little bit about this already. So it states the sum of the angles in any triangle equals 180 degrees. And one of my very favorite lessons to do with my class to teach this is I have them take a straight edge and draw any triangle, and then measure the 3 triangles using a protractor. So this one equals 70. This side equals 60, which means that side should be 50. So do 60 plus 70 plus 50 equal 180. What's kind of cool about this And so what I like to do is do this in a small group and have everybody make a different type of triangle, measure all three, and then add them up, and we see like how all the different types of triangles all equal 180. Another cool way to do that is to do this and then cut it out, cut this triangle out, and then tear these off. And then when you line them up, it will make a straight angle, which is equivalent to 180 degrees, right? So that's like the way to actually prove that this works, this triangle angle sum theorem. And then the other thing that you need to know is the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So what that means is on this triangle, if I have A and B and C, if I add A and B up, A plus B, it's going to be greater than C. If it's not greater than C, then that triangle's not going to work. So basically, if A equaled 4 and B equaled 2 and C equals 8, this triangle, it's not really a triangle. Like if I actually measured those out, I cannot get a triangle that has 8 inches on one side, 4 inches on another, and 2. It won't match up. Like no matter how you try and do it, it's just not going to work. So when I add these two sides up, it has to be greater than the third side in order for it to actually close and be a triangle. So it is possible to draw a triangle with the side. Is it possible? We got to figure this out. Is it possible to draw a triangle with the sides measuring 2 centimeters, 3 centimeters, and 6 centimeters? So using the theorem, we can add two sides together, and it's got to be greater than the third. So let's do that. We added 2 plus 6, which is it greater than 3? Yes. 8 is greater than 3, so the inequality 8 plus 6 is greater than 3 is true. Let's try another one. So 3 plus 6 is greater than 2. 9 is greater than 2, so yes, that is true. But 2 plus 3 is not greater than 6. 5 is less than 6, so the inequality 2 plus 3 is less than 6 or is greater than 6 is not true, so it does not work. It has to work for all combinations. So if like you look back at this triangle, it would have to work for A plus B would have to be greater than C, A plus C would have to be greater than B, and B plus C would have to be greater than A. So if you look down here, this triangle, like no matter how you tilt these, like if I push this in a little bit further, they're never going to match. They're never going to hit a point and make it an actual triangle. This isn't even a polygon because it's a open shape. It is impossible to draw a triangle with the sides 2 centimeters, 3 centimeters, and 6 centimeters. In the space below, construct a right triangle with two sides measuring 1 inch. Is the third side longer or equal to the 1 inch length? So here is, it says a right triangle with two sides measuring 1 inch. So I'm just gonna make the two legs of the triangle 1 inch. And the last leg is 1.5 inches. So here's my right triangle, 1 inch, 1 inch, 1.5. Now I'm gonna try it a different way, and I'm gonna do one of the legs and the hypotenuse 1 inch. So here's 1 inch, the hypotenuse is 1 inch. I can make this 1 inch because it's an equilateral triangle, right? But there's no right triangle there, right? So a right triangle cannot also be an equilateral triangle. The two sides here are going to be smaller than this side. But the sum of these two sides, 1 plus 1, is greater than 1.5. So it does work. All right, let's keep going. Is it possible to construct a triangle with the measures 30 degrees, 50 degrees, and 100 degrees? Well, 30 plus 50 plus 100 equals 180, so yes it is. If so, can you draw one unique triangle or many different triangles? So is a triangle possible? This equals 180 degrees, so yes, possible, or it is possible. I guess, so the triangle is possible. Use a protractor to draw a triangle with those measurements. So here's a protractor, or here's a triangle that we did here. One possible triangle is drawn for you. In the space below, draw a second triangle with the same angle measurement, but which is larger or smaller from the first triangle. So basically, like, this is what we talked about at the very beginning of this, or the beginning of video 1, is you can make a similar triangle. Like, I could make a larger triangle here, but the measurements can be the same. Like, I can go all the way up, like, make this really long and still make this 100. Wait, this is 100. Yeah, this is 100. So there's 100. It's right there. 100. And then that needs to be 30 over there. So this is 30. And then this one should be 50. Yep. So yeah, this is 30. This is 100. This is a 50. Now I can't necessarily come up with a like unique triangle, but I can say I drew a similar triangle to the first triangle because its corresponding angles are congruent. It blank possible to draw many different triangles with the angles measuring. Yeah, I mean, you can draw like tons of different triangles. They're just all going to be similar. So it is possible to draw many different triangles. Like, this is a different triangle than this. They're similar, but they're not the same. They're not congruent. All right, what does the triangle angle sum state? That all angles added together equal 180. What does the triangle inequality theorem state? That the sum of two sides must be greater than third side. All right, so what you're going to do is you're going to prove whether these 4 triangles can be triangles by adding the angles together and making sure they have to measure, they have to get exactly 180. Now, sometimes when you create a triangle with a protractor, you may not measure it completely accurately. So you might get, like, I always have students that have like 71, 58, and 47. And when we add them together, it gets to be like something very close to 180. It's just because they just measured off a little bit. So just add these up and they have to get exactly to 180. If they don't, they are not triangles. And then same thing with this. So is it possible to draw a triangle with the given side lengths, right? Yes or no. So basically you're trying out all the different methods. So I'm going to do it down here, or all the different add-ins. 5 plus 6 needs to be greater than 12. It is not. Excuse me. It's not greater than 12, so like right away that does not work. But if you were to like flip those around, if you did 12 plus 6, that is greater than 5, so that works. Or 12 plus 5 is greater than 6, that works. But 5 plus 6 is not greater than 6, so that one does not work. So you have to try all 3. Love the word problems here, and then you get to do your own here. If you do not have a protractor, You can just draw it as similar as you can. And then you're going to say, is it unique or can you draw different ones? Yes, you can. Or can you? 90 plus 90. Yes, you can. And then this one, you are going to try to do over here too. And then a good old word problem down there. So obviously finish these up. If you have any questions, you can email me or Google chat with me, and I'll do my best to help.